Today's, well, okay, this will be actually the second video that I've made today, but um, today's video, we'll just call it that, is on really position in relationship to the normal curve, which we refer to as percentile, um, and probability, normal CDF, INV norm, as well as how to use all of this tied together. So first of all, what is a z-score? Well, when we are dealing with uh, data, um, and specifically when we're looking at the normal curve, if I draw the normal curve and I just create some artificial mean and standard deviation, and I often use IQ for this because IQ people, you know, seem to have some idea what it is. The mean on an IQ is 100, and the standard deviation is 15. Now, there are other IQ standards that are set up, so some are 100, and then there's 12.5, and I'm just using one that I'm familiar with. So, the z-score is a count. It is the number of standard deviations away from the mean. That's what's right here. The data point is. So let's just sort of build this in two forms. We're going to build it in raw data point land and then in z-score land. And then we're going to connect it to the empirical rule for a sec. And then we're going to try and talk about percentile in this mix. So the mean is 100, so the 100 sits dead center. Now, here's the question. How many standard deviations away from the mean is the mean? In other words, the z-score is 0. And if we look at our z-score formula, which is right here, what we do is we take our raw data point, which is 100, because we asked what's the z-score for 100. We're going to subtract off the mean, this mean, and then we're going to divide by the standard deviation, this standard deviation. Well, 100 minus 100 is 0, so the z-score for 100 is 0. Now, we're going to go one standard deviation to the right and one standard deviation to the left. Well, we've just described our position as 1 and -1. This is going to be 85, and this is going to be 115. And if we take the 115 and we plug it into this formula up here, here's our 1 and our 5. So it's 115. Sorry for writing over. I probably should erase that. I will do that. I will click, and then I will go back to here, and I will get the, there we go. So 115. And so 115 minus 100 is 15. 15 divided by 15 is 1. So the z-score is 1. And you can get halves and quarters and so forth. So if you did 105, you type 105 in here, so you'd have 5 divided by 15, so you'd be at a third. So your z-score is a third. Now, I hope that makes sense. I'm going to go to the next one, which is 130, which is 2. A z-score of 2, so you take the 130, plug it in. 130 minus 100 is 30. 30 divided by 15 gets you the 2. And then we're over here to 145. My poor dog's stomach is upset, and she ate something again. She eats stuff, often eats socks. She has a big thing about socks. I don't understand why, but when she does, her stomach like growls and pings, and it's a bit goofy sometimes. So I'm just working down to what is typically done 3 and -3, but they actually go on. So you'd have 4, and this would be 160, and it just keeps going that way. And same thing here. So here's a 40, and this would be -4. Now, we had talked about the empirical rule, and that from this mark all the way to -infinity, gray stop, is point. She's going to bark, so apologies. Just a sec. No. She's getting all grouchy with people walking by in our front yard. Grace, sit. 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 Grace, sit. Sit. Good dog. Stay. Sorry, folks. Okay, so remember it was 0.0015 for all of the standard deviations to the left of the third standard deviation. And then this little wedge here was, well, 0.00235. I'm sorry, 0.0235 or 2.35%. Okay. Now, if we add these two values up, we are at 2.5%. And so 70 is the raw data point that has 2.5% to the left. Okay, so the z-score that has 2.5% of the area to the left is -2. And the reason I'm emphasizing that is percentile is a measurement of comparison to the left. Now, I know I've said that in a previous video, but it comes back here. So when I'm talking about percentile, I'm talking about what am I above? I am above 2.5% if my IQ is 70. If I'm at the z-score of -2, I'm above 2.5%. If my IQ is 85, and remember, this was 13.5%, so that would be 0.135. And if I added these up, it's somewhere close to 16%. So I'm at the 16th percentile when my IQ is 85, meaning I am above 16% of the population. I'm at the 16th percentile when I'm at my z-score of -1. So the question is what z-score is the 50th percentile? Well, the 50th percentile is here because half of the data is to the left. So the z-score is 0. What is the z-score at the 20th percentile? What's the z-score at the 84th percentile? Well, the 84th percentile we can do reasonably quickly because if we recall, we had 34% here and we had another 34% here. And if we add up everything to the left, that's 50% or 0.50, and 0.50 plus 0.34 gives me 84. So the z-score is 1 on that one. The raw data point on that one would be 115. Now, we need to answer this question. So, what is the z-score that represents the 20th percentile? All right, so I'm going to give you some keystrokes on your handy-dandy graphing calculator, and what we're looking for is INV norm. And INV norm always counts up the area from the left. It's actually a percentile counter. So what you do is you hit the second key, and then you go to vars, and you look for the third one, INV norm. And when you hit INV norm, it depends on if you have an old calculator or not. But what you're going to see is either it says INV norm, and then all you have is a set of like a parenthesis there, or you have INV norm and then it says area, mean, standard deviation, and paste. Well, that's the order that we deal with here. So it's the area, comma, the mean, comma, and the standard deviation. So to be in z-score land, what is referred to as the standard normal curve, our mean and our standard deviation need to be 0 and 1. So a reminder that this is the mean, this is the standard deviation, and this part here is the area to the left. Now the area to the left is going to be 0.20 because we want the 20th percentile. So we're going to type in 0.20. I'll do that in my calculator, and what I get is a negative 0.84. So the location, not the area, the location on the number line is negative 0.84. So over here, we're on the negatives. I'm in the z-score land. I'm not in raw data point land. I'm in z-score land. Negative 0.84 is almost to negative 1. So I'm going to use a different color. I'll use blue. So we're somewhere in this vicinity where we're talking about negative 0.84. Negative 0.84 has 20% of the area underneath the curve to the left. Okay? I could ask, what would be the not the 50th, let's do the 70th percentile. Well, what would change was this 2 that's here would now become, I said the 70th, I'd put the 0.70, and I would erase that, and that. And I know that it's going to be positive because this value is larger than a half. So the 70th percentile should be somewhere in this vicinity where my little arrow thing is pointing to. So let's type in the 0.70 into our INV norm. So second vars INV norm. We're going to type in 0.70 for the area. The mean again is 0. The standard deviation is 1. That's how we know we're on the standard normal curve. And we're at 0.52. So 0.52, well, here's the 0, here's the 1. Halfway between would be 0.5. So we're a little bit to the right of the halfway mark between 0 and 1. So there's our 0.52. The area to the left of that is going to be 70%. 70% of the area of the normal curve is to the left of the z-score, 0.52. Now, we could ask the question, what's the raw data point that represents that 0.52? And I'll show you a little trick on your INV norm. So what you do is you take your second vars, your INV norm. So we go second vars, and you go to INV norm, and you leave the 0.70 as the area, but you change your mean and your standard deviation to meet your raw data point information. So the mean is 100, and your standard deviation is 15, and it will automatically convert it for you into raw data. And the raw data point, the z-score is 0.52, reminder, but the raw data point is 107.866. So the IQ that is the 70th percentile is about 107.8. Okay, so far so good, I hope. Now, suppose the bonsai tree has a mean of 14 inches. Well, this entire graph that we have here can be redrawn, but what happens is that instead of 100 in the middle, you have 14. And the z-score for the 14 is 0 because it is the mean. Now the standard deviation is a half, so this mark here is 14. Here's our 14 and a half. Here's our 15. So here's our 14.5. Here's our 15. And then here we're at 15.5. And then we go back the other direction. So we're at 13 and a half. And then 13. then 12.5. And again, we typically just go out to three standard deviations away in both directions. And then from here on out, from this mark on, we just say, oh, it's about 0.15%, and from this mark out that way, it's about 0.15%. Right, so we're going to ask the question, what's the probability of selecting, that's supposed to be at random, so I will put a little t there, at random, a bonsai tree whose height is more than 15 inches. So we want to be more than 15 inches. We're looking here off to infinity. Okay, well, I showed you the use of INV norm, but normal CDF is what actually will work from z-scores and gives us areas, or raw data points and gives us areas. So you're going to type in second vars, and you're going to find normal CDF, C, not P. We never use number 1 in this class. So second vars, normal CDF. The lower, the left mark, is going to be 15. Is going to be 15. The upper, we don't have an infinity button on our calculator, but what we can do is put something very, very large there. So put 1 with a bunch of zeros. Now, to make it work in raw data land, use the mean of 14 and use the standard deviation of 0.5, and then go ahead and hit paste, and you're going to get a probability of 0.0227. So I will write 0.0227. Now, what if you wanted to have a height who's between 13 inches and 14 inches? So it would be between this mark here and this mark here, between 13 and 14 inches. Well, we're going to do that same thing. Second vars, and you're going to go to normal CDF. Now your lower is the left-hand mark, so that's going to be 13. Your upper is going to be 14. And then leave your mean at 14 and your standard deviation at 0.5, and you go ahead and go to paste and hit enter, and you're going to get a probability of 0.477, and then I'm just going to stop after the 2. So you get a probability of that when you're saying, all right, I'm trying to find A, that's 1, randomly selected bonsai tree, that's between those heights. And I do need to point out that when you're dealing with continuous variables, you deal with probability over intervals. When you deal with discrete, like we did in the previous video on binomial PDF and CDF, you're dealing with count data, like 1, 2, 3, 4. So you're dealing with the probability of just one individual value. And if you go back to your histograms, that is where you go from 0.5 to 1.5, 1.5 to 2.5, and you get those rectangles that are above those integer values. Now let's do one last one. Let's do a normal let's do the probability of less than, and we'll say just less than 13. Well, that is this region from 13 off to negative infinity, but we don't type it in that way. We always work with our calculator from left to right. So how do we make that work? And this one's always the one that tends to create issues. So what we do is we go second vars, and we're going to do normal CDF. But our lower is negative infinity, and we don't really have an infinity button. So what we do is we type the negative button. Now don't hit the subtract key. The subtract key is on the column on the far right. The negative key is down at the bottom, and it is below the 3. So you're going to hit the negative key. You're going to hit a 1 with a ton of zeros. I've put negative 1,000,000. And then our upper is going to be the 13, and leave the mean 14 and the standard deviation 0.5. We hit paste, and we get 0.02227 again. Well, and that should make some sense to you, because I hope that you're starting to figure out that the normal curve is symmetric. And so from 13 off to negative infinity should match 15 off to positive infinity. Okay. I will point out there are some other ways to do this. You can do it in terms of z-score land. And I don't know if it's going to come into play or not. So it very likely will. But right now, I think that's enough information for this video. Note, I've said that this is a z-score formula. There's about, in our class, let me think about that for a second. There's 3 or 4 different z-score formulas we run into throughout the course. So understand that this is the first one, and then the next one will be coming up fairly quickly. All right, I hope that this video helps. Have a good day.